I would like to call all the way to Japan to start with. Adrian, are you there?
Yes, can you hear
Great.
me?
Great. We hear you. And let's see if we can see your slides as well.
Yes, that's the first challenge. If we resolve this, we are well on the path. Okay, are you seeing the screen or are you seeing my
It,
screen?
it looks great. Take it away, Adrian.
Okay. Hello and konnichiwa. My name is Adrian. I am a VP of Global Sales here at Hacarus, and I'm dialing in from Kyoto, Japan. So I'm just about to embark into Friday, whereas I think most of the people in Europe, you're still on your Thursday afternoon. I'm excited to share with you our award-winning solutions for smart infrastructure here at the Things eBazaar. First things first, if this presentation sparks your interest, you'd like to learn more, schedule a demo, or conduct a free feasibility study with your data and our AI, don't hesitate to reach out. You can contact me at adrian@hacarus.com. So I just want to give you a snapshot of who we are and where we come from. So Hackers was founded in 2014. Over the past 7 years, we've grown across Japan into several heavily industrialized areas, including Tokyo, Kobe, as well as Kyoto, where we're originally from. It's a global team, so we're able to support our customers in Japanese, English, German, Chinese, and Swedish. I actually happen to be Swedish. What we specialize in is building tools that allow you to predict or understand what's happening with image-based assets. So things like radar images, still images, video feeds, and even satellite images, or time series data. These are things like sounds and vibrations. And what we are able to do is predict and understand anomalies, defects, and errors. Uh, what I wanted to jump in today is more specifically what we do in the space of smart infrastructure. So what we do is we build custom AI solutions that solve for a variety of problems in this space using our proprietary sparse modeling based AI technology. And the benefits of sparse modeling can really be summarized in four key areas. The first one is around resource efficiency. So it uses far less energy and far less compute power for prediction and training. What this means is you can typically run our models on a normal laptop or in some cases even on a tablet. You don't need industrial grade computing, and that also has a benefit in being much more environmentally friendly. The second part is about frugality. Frugality means the ability to create highly accurate models for prediction with small data sets. We can get started with as little as 50 samples and still create a highly accurate model. A third part is about explainability. And this is all about showing the reason why our model has made a certain recommendation or a certain prediction. With conventional AI technologies, typically it's quite difficult to understand the decision-making process due to the complexity of the neural network involved. With sparse modeling, we're able to be far more efficient in this regard through something called dictionary learning. The final part is about the flexibility that I started off with, talking about how we can work both with image data or time series data, and in some use cases, actually combining both. So far, I think it's been on a very high level. So I would like to now give you three concrete examples of things that we've built in Japan for customers that are using this technology. I want to focus on a use case for radar data analysis, as well as a use case for inspection and reading of instrumental tools using a partner company with a drone, as well as unsafe behavior detection on construction sites. So all things that are in the space of smart manufacturing and smart infrastructure, but not necessarily in the original use. So the first use case I want to zoom in is on radar data analysis. So this customer is a large firm here in Japan in the energies and utilities space. And the use case is looking at analysis of ground penetrating radar imagery. So basically, before you start digging up a street, you want to know what's underneath. Am I going to hit a gas pipe? Am I going to hit a wire? Am I going to have some kind of problem? And the way to know this today is typically to use one of these machines on the picture. This is a machine that scans the ground and produces a radar image or several radar image of what's underneath. However, the inspection tasks is done by a human expert that looks at the image and classifies various shapes within the image as this is a rock, it's okay to dig, this is a pipe, this is not okay to dig. So what our customer wanted us to do was, can you take that human expertise and build that into a model that they can replicate that prediction? And that was really what this project was about. We started this work 2 years ago and is now commercially deployed across Japan. We've brought this project also to Europe with a large firm in Germany recently. So automating object detection in radar imagery ahead of construction. The second use case I want to zoom in is on instrument reading and inspection. Again, large player in the gas space. We use natural gas a lot in Japan. And what they had a problem of is today they have human inspectors that go out and look at each and every instrument that they have in their various utility sites to make sure that nothing's wrong, and they have to do this on routine. The problem is it takes a lot of time. You have to use ladders, and it's a bit of a dangerous, a workplace hazard potentially. People can fall and hurt themselves. So what we did is we partnered with a company here called Liberaware that makes industrial grade drones, and we embedded our image recognition and detection capabilities with the computer on board that's in the drone. So we can do localized predictions and readings of these tools, which in the end saves time, money, and reduces potential workplace accidents. The third use case I wanted to talk about is about unsafe behavior and object detection. This is a large Japanese construction firm that we worked with, and the use case is all about human body part segmentation and object detection. More specifically, what they wanted to do is understand if workers are wearing appropriate safety gear or notify when they're not. Are they wearing the right hard hat? Are they wearing the right glove? Are they staying out of unsafe areas? So what we did is we devised a tool that runs on top of a CCTV camera video feed and is able to segment human body parts to understand which parts should be covered and which are okay not to be covered, as well as classify objects that they should or shouldn't be using and areas they should and shouldn't be. This is a cloud-based module, but we've been able to commercialize it also for tablet and laptop use. All of these three use cases that I've presented here are using our proprietary core technology, but are different ways that we applied it for a customer. The next part I wanted to talk about is sort of giving you a bit of an idea of where we are and where we come from. So at Hacarus, we spent the past 7 years working on this technology, and our core team of 70 consists of Japan's arguably most qualified data science talents. And we're ready to bring this capability also to use cases outside of Japan. We work closely with Kyoto, Tohoku, and Shiga University on our core technology. And today we supplied our solutions to firms such as Mitsubishi Electric, Yanmar, Hitachi, and Osaka Gas. So if I can only leave you with 3 things and you only remember 3 things from me today, I'd want you to remember this. We have delivered superior AI inspection capabilities and solutions for a wide range of infrastructure use cases. We're building on strong traction in Japan right now, and we're bringing this to global customers. And we're likely to be able to work with you in your local language. And if you would like to learn more about Hacarus and how we can help you solve your challenges or achieve your AI goals, just reach out to me, Adrian at hacarus.com. Thank you so much. Magnus, you appear to be muted.
I am muted. Brilliant, brilliant, Adrian. And as always, sharp and to the point and very exciting to listen to. Let's see if we have any questions in the chat for you. There's a lot of things in the chat, but I didn't see any specific question for you. No. So okay. I'll leave you with that. And then I will also tell the audience that this is actually pretty late in Japan. So you will not stay, I guess. Or if you don't stay to the end of this for other questions and answers, well, you're excused. And we are so happy to have you here, and thank you so much, and see you soon again.